So for these videos, we're focusing on the pre-calc part of parametric equations. So we'll be graphing this parametric equation and then eliminating the parameter to get rid of all the t's. So the parameter, the t, is basically just adding time in. So at a certain time, where is your x value, where is your y value? So you can start looking at rates of change of time with just normal equations. So one thing you want to look at is see if you have any restrictions on the t's, and we do. We have a square root. We know we can't have a square root of a negative. So the smallest my t value can actually be is a -1. -1 plus 1 is 0. So I'm going to say that I'm going to start and I'm going to make a chart here. And my first t value I'm going to look at is -1. Now your normal charts are xy charts, and we are going to do that as well. So it's x and y. I'm just adding the parameter of t -1. So when time is -1, what is my x value and what is my y value? So I will actually go plug these into the equations, plug the -1 in. So I know that my x value is 0. If I take the -1 and plug it in over here, -1 plus 2 is a +1. So I know that I have a point that's 0, 1 on my graph. I'll put that right there. The next value I might try, I know that my t values have to increase times passing, but I also know I can't have negative t's, would be a 0. Well, the square root of 0 plus 1 is the square root of 1, and I know that that's 1, so my x value is 1, and then my y value will be 2. So when time is 0, my point is at 1, 2. For my next point, I'm going to pick some nice values here. I don't want to have to deal with an ugly square root, so I'm going to say t is equal to 3. And I know that the bigger t gets, the bigger my square root will get, so I'm not destroying some kind of trend or anything or missing something that's going on here. But when t equals 3, I have 3 plus 1 is 4. The square root of 4 is 2. And then I have a 5. So 2, 5 is my point. I'm going to do one more point. The next nice thing to look at after 4 would be 9, so my t would be an 8. So 8 plus 1 is 9, the square root of 9 is 3. And then over here, 8 plus 2 is 10. So you can see that my y values are increasing much faster than my x values. So when t equals 3, we're going to be way up here. Okay, so what I would do if I was drawing this in, sketch the curve in, and it looks like half of a parabola for a reason. There's no high value of t that I've been given or that's controlled by a function, so I'm going to put an arrow, but I'm actually going to add some other arrows as well. And that's to show the direction that's going on. As time increases, where am I going? Am I going down and to the left or up and to the right? And we knew from the way we drew it, 0, 1, 2, 3, we are going to the right, so I'll add a few extra arrows that show the direction as time passes. So the next thing we need to do is actually eliminate the parameter. And to do that, what that means is get rid of the t's. You just want x's and y's. So you're drawing or you're writing the equation of this line. So our equations usually start y equals, so I'm actually going to keep this y equals right here. And I want to get rid of this t and put some x's in. So the way you can do that is come over to your other equation. We're using substitution, and I'm going to solve for this t. So to solve for this t, the very first thing I would do is square both sides. So I know that x squared equals t plus 1. So then I'm solving for t, so I'll subtract 1. So x squared minus 1 equals t. And now I can substitute into this equation here. So I'd say y equals x squared minus 1, that's the t, plus 2. Or y equals x squared plus 1, which should make sense. This looks like half of a parabola, and it's been shifted up 1. So this is the equation of the full parabola, but I only have half a parabola, so it's important to actually restrict either the domain or range depending on what you're doing, what kind of problem you have. This one, I can't really restrict the range because if I say go from 1 to infinity, I'm going to get both sides of the parabola if I'm using this equation. But if I say x is greater than or equal to 0, then that actually restricts the range. I'm starting when x equals 0 and going to the right, so it restricts the domain, and we actually get the equation for what we're showing here.